If you test a Schottky diode the same way you test a regular diode, there's a good chance you'll throw away a perfectly good part. Schottky diode reads completely differently on a multimeter, and in the next 5 minutes I'm going to show you exactly what a good one looks like, what a bad one looks like, and the one reading that fools almost everybody. Today I'm going to show you how to test a Schottky diode using nothing but a basic digital multimeter. Before we grab the multimeter, let's take 30 seconds to talk about what makes a Schottky diode special, because it directly affects the readings you're going to see. A standard silicon diode is built from a junction of P-type and N-type semiconductor material, and it has a forward voltage drop of roughly 0.6 to 0.7 volts. A Schottky diode is different. It's formed by a junction between a metal and a semiconductor. That construction gives it two big advantages: a much lower forward voltage drop, typically somewhere between 0.15 and 0.45 volts, and very fast switching speed. That's why you'll find Schottky diodes everywhere in switch mode power supplies, DC to DC converters, solar panel blocking circuits, and reverse polarity protection. Alright, let's do the actual test. Set your multimeter to diode mode. The diode mode symbol is a small triangle pointing to a vertical line. I have to cycle through the function button to reach diode mode on this multimeter. Every diode has two terminals, the anode and the cathode. The cathode is marked with a band or stripe on one end of the body. First, let's get a reading of a regular silicon diode. Take the red probe and touch it to the anode, and touch the black probe to the cathode. This is called forward biasing the diode, and in this direction, a healthy diode should conduct. As expected, the reading shows around 0.6 volts. Now, let's switch to a Schottky diode. You can see the meter reads about 0.2 volts. If you're used to testing standard silicon diodes, 0.2 volts looks like a failing part. It looks like the junction is breaking down and heading toward a short. That low reading is completely normal for a Schottky, and it's actually a handy way to tell a Schottky apart from a standard diode if the part number has rubbed off. So burn this into your memory. Low forward voltage on a Schottky is not a fault, it's the feature. Now, swap the probes. Put the red probe on the cathode and the black probe on the anode. The meter displays OL, which stands for overload or overlimit. This reverse biases the diode, and a good diode should block current in this direction. I have another Schottky diode that I want to test. Let's start the same way we did before. Touch the red probe on the anode and the black probe on the cathode. And look at that, the meter reads 0.003 volts, basically zero. But one reading by itself doesn't tell the whole story, so let's confirm it by reversing the probes. Touch the red probe on the cathode and the black probe on the anode. This is the direction where the diode should block completely, and the meter should show OL. Instead, I'm getting 0.004 volts, the same near zero reading in both directions. That's the signature of a dead short. This is a bad diode and should be replaced. And that's it. That's how you test a Schottky diode with a multimeter. If you want to learn more about building circuits and electronics from the ground up, check out my Getting Started with Electronics ebook. It walks you through the fundamentals, components, tools, and how to read and build real circuits, so you can start designing your own projects with confidence. The link is in the video description. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.